Hello everyone, welcome to another video. We will be discussing more numericals on quantum mechanics. The topic we have just finished, that is your mathematical tools in physics. So we'll be solving questions from Jetli. Okay, so I hope you have the book with you. Still, I will write the questions. Okay, so I'm solving Jetli numericals. Okay, so this is the second chapter. So, let's try to start the questions. First question will be: consider the Hilbert space. Consider the Hilbert space of two variable complex functions two variable complex functions psi xy. A permutation operator a permutation operator permutation operator is defined by its action on psi xy as follows: uh, pi xy is equal to psi xy. Okay, so question is verify that the operator verify that the operator pi is linear and Hermitian. Okay, option B, so that pi square is equal to I. Yeah, I is a unit operator. Find the eigenvalues. Find the eigenvalues and so that the eigenfunctions the eigenfunctions so that the eigenfunctions of pi are are given by given by psi plus xy is equal to half psi xy plus psi yx, okay, and psi minus xy is equal to half psi xy minus psi yx. Okay, so this is the question. Read the question first. Read the question properly. See, consider the Hilbert space of the two variable complex function psi xy. Okay, a permutation operator is defined by its action psi xy as follows: pi xy is equal to psi xy. Verify that the operator pi is linear and Hermitian so that pi square is equal to I, and find the eigenvalues so that the eigenfunction of pi are given by this and this. Okay, so here in this problem, if I try to solve this, see here in this problem we are given the what permutation operator. That is a pi psi xy is equal to what? Psi yx. We have been given this, right? Pi xy equal psi y. Okay, my bad. This is psi yx. Okay, psi yx. Okay, pi xy is equal to psi yx. So we want to first of all what? Verify what? First question is what? Verify that the operator is linear and Hermitian. So we have to verify operator pi is linear and Hermitian. Linear and Hermitian. Okay. So how will we solve it? So in order to show that this operator is linear, we need to have what? What we need to show? We need to show that, for example, psi is your, suppose psi xy is your linear combination of psi 1 x ay, okay, uh, plus psi 2 bx by. Suppose like this. So if I operate pi on it, when pi will be a linear operator only when, if I get something like this, if I operate pi on this whole thing, psi 1 ax ay, the psi 2 bx by, if I operate on it, I will get it as what I will get. I will get a psi 1 xy plus b psi 2 xy. Okay, I will get this. Okay, if I operate pi on it, I will get it. So this only this time we will know what, that pi is your linear operator. Okay, yeah. So this is it. This is a linear operator. And how to know that this operator is Hermitian? How to know the operator is Hermitian? See, how to know its operator is Hermitian. See, for Hermitian, we will show that what, psi 1 xy pi psi 2 xy expectation value is equal to what? Is equal to what? Psi 1 xy pi psi 2 xy whole star. Okay, that means complex matrix. Complex. Or psi 1 xy pi psi 2 xy is equal to what? If I use it inside, that will be psi 1 xy pi dagger psi 2 xy. Sorry, psi 2 xy pi dagger psi 1 xy. Okay, is it alright? Hmm. So from here we can get that, but psi 1 xy psi 2 xy psi 2 yx. Okay, if I take this inner product, I will get what? Psi 2 xy psi 1 yx. Okay, is it alright? This is from your definition, and this is also your definition, right? Yeah. So from here we can prove that this pi is Hermitian. Okay. Yeah. Next, what we have to show? What we have to show that pi square is equal to I. Find the eigenvalues. Okay. Let's try to find it. It's a bit a theoretical question. Okay. A bit of logic is required. We have to show pi square is equal to I. Okay. So let's pi square is equal to I. We have to prove. So suppose I operate pi square on psi. That means I can write this pi psi xy, right? So We have been given in the question pi psi xy is equal to psi yx. So let's put it here. So pi, this becomes psi yx, and if I operate it again, this order will just change as the order changed here. That will be again psi xy. So in the end, I got pi square is equal to this pi square psi xy is equal to this. So if you see what if I operate something on a psi is equal to psi. So when it happens, only when a is a unit operator, okay, then I will get the same one. So here from here I can prove that pi square is equal to 9, okay, because it's not changing the and the eigenvalue. If you see what is the eigenvalue here, what are the eigenvalues of I here? Here pi square is equal to what? Suppose pi square psi xy is equal to lambda square psi xy. And if you see lambda square is how much here? There is nothing, that means 1. So lambda square is equal to 1. That means lambda is equal to what? Plus or minus 1. So this is your what? Eigen there. Okay? Is it alright? Okay. Yeah. So this was what your question was about. Hmm. Okay, we'll move to the next question now. The next question is exercise. Let me write the exercise name. Exercise, this is for Zettili. This is the exercise 2.55, and starting from the last part. Exercise 2.54. So if A and B are two Hermitian operators, find their respective find their respective eigenvalues, find their respective eigenvalues such that such that A square is equal to 2i and B fourth is equal to I, where I is the unit operator, where I is the unit operator. Is it alright? If A and B are two Hermitian operators, find their respective eigenvalues so that A square is equal to 2i and B fourth is equal to I. So this is given. A square is equal to 2i and B fourth is equal to I are given. Okay. So we have to find the respective eigenvalues. So let's see. Try this question first. A square is equal to 2i, B fourth is equal to I. So how to solve this? So A square is equal to 2i. Suppose A psi, I operate on psi, I will get suppose A psi. Okay. So A square psi will give me A square psi, which is which is what? If I okay, A square is what? 2i psi is equal to A square psi, right? So 2i means exactly like the value is 2, right? 2 psi is equal to A square psi, isn't it? Right. So A square is equal to 2, right? Eigenvalue. So A is equal to what? Plus or minus root 2. Okay. A is equal to plus or minus root 2. Easy, very easy. So for this, The eigenvalues are what? Plus or minus root 2. Now for let's do for this one b fourth. B fourth is equal to sorry, b fourth is equal to I. Let me okay, b psi is equal to b psi suppose. So b fourth psi is equal to b fourth psi. Then b fourth is I. So I psi, right? B fourth is equal to I, na? I psi is equal to b fourth psi. So b fourth I eigenvalue is 1. So b fourth is equal to 1. So b is equal to what? Plus or minus 1 again. Plus or minus 1, plus or minus 1. So four values now. 1, 1, minus 1, minus 1. Right? Yeah. Otherwise, no, 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 no. Sorry, sorry. B fourth is equal to I, right? Yeah, I fourth is also 1 is equal to 1. So yeah, plus or minus 1, plus or minus I. Okay. Otherwise, we can solve it. No problem. B fourth is equal to 1. B fourth minus 1 is equal to 0. This can be written as b square minus 1 square is equal to 0, right? So b square square minus 1 square. So I can write as a square minus b square, that is a plus b whole into a minus b is equal to 0. Okay, see how much can we do it here. So b square is equal to minus 1, b square is equal to 1. So b is equal to plus or minus I and b is equal to plus or minus 1. Okay, so four values 1 minus 1 I minus I. Okay, yeah, these are the values. Easy question. Just have to know like this equations and all. Is it clear? Okay, we'll move to the next question. Exercise 2.53. Consider an operator. Consider an operator A is equal to x dy dx plus 2 a. Find the eigenfunction of a of a corresponding to zero eigenvalue, corresponding to zero eigenvalue is this function normalizable? Is this function normalizable? Option B. Is the operator a Hermitian? Is the operator a Hermitian? Option C. Calculate calculate ax a dy dx a d square by dx square x then x a comma x dy dx a dy dx. Okay, we have to take the operator a is equal to x dy dx plus 2. Find the eigenfunction of a corresponding to an zero eigenvalue. Is this function normalizable? Is the operator a Hermitian? Calculate this. Let's try. Try this question. Okay, what is the operator? The operator is given as x dy dx plus 2. If I take psi on, if I operate this on psi, a psi is equal to x cap dy dx plus 2 psi. A psi is equal to x d psi by dx plus 2 psi. Okay. Suppose a psi is equal to a psi. Okay. Suppose the eigenvalue is a. So a psi is equal to uh, let me write this x. The eigenvalue of x is x, right? Anything is x, right? So x. Let me write it x. D psi by dx plus 2 psi. Let me arrange it a bit. X d psi by dx plus 2 psi minus a psi is equal to 0. I just went to this side. X d psi by dx 2 minus a whole psi is equal to 0. Okay. So um, x d psi by dx is equal to, I can take to this side a minus 2 psi. Okay. So I will just separate the variables. So d psi by psi is equal to a minus 2 dx by x. I will take the integration on both sides. So this is a ln psi is equal to a minus 2 ln x. Is it alright? Ln psi is equal to a minus 2 ln x. So psi is equal to what? C e whole into a minus 2 ln x. So it can be written as e to the power a minus 2. Okay. Okay, I can write it as e to the power ln x to the power a minus 2, isn't it? So x to the power a minus 2, I can write it as like that. Psi is equal to x to the power a minus 2. Okay, this is your psi. So for what is the question? Find the eigenfunction of a corresponding to zero eigenvalue. So zero eigenvalue, that means what? A eigenvalue we have taken what? A psi is equal to a psi. So your a will be zero. Okay, so for a is equal to zero, what is the eigenfunction? Psi is equal to x to the power minus 1. Next. Okay. Okay, let me put a normalization constant, suppose c here. Okay, and that's very necessary because the another would have come here, right? And then c, right? So c will come here. So c integration constant. Okay, c, so c by x. So next question is this function normalizable? Okay, what we got? We got psi is equal to 1. Sorry, c by x square. Is this normalizable? Let's see. So psi star psi dx integration minus infinity to infinity. Okay, let's see whether it is coming 1 or not. So this will be c square 1 by x fourth dx minus infinity to infinity. Okay, so that will be c square. It will be x to the power minus 3 by minus 3 minus infinity to infinity. Okay, so if you see this is coming as 0, this minus 3 goes out. So if you put the value infinity, sorry, 1 by x3 infinity, this will be coming 0, which is no, this is not normalizable. Okay, this is non-normalizable because the integral will be 0 and it wouldn't be normalizable. Okay, so this is non-normalizable. Next question is what? Is the operator a Hermitian? Check. So the operator is whether it is Hermitian or not. See, first of all, what is your psi? Psi is this c x to the power minus 2, right? So if a is a okay, x to the a minus 2, sorry, x to the a minus 2. So suppose a is a complex number. Suppose a is I. Okay, psi. So if I take the psi star, that will be what? Or psi dagger. C h to the minus. So this is not your psi, right? So psi is not equal to psi dagger. So this is not omission. Okay, this function is not omission. Okay, is it okay? Hello, 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 hello. Okay, next question is this one. We have to calculate the operators. Let's do one by one. Ax. So what is your a? A is your this. So you have to find ax. So your a is your what? A is your x dy dx plus 2. So ax we have to find out. So x dy dx plus 2. Sorry, x dy dx plus 2 comma x. Okay, so let's find out. We have to give a wave function a psi. Okay, otherwise it's not possible. So that means x dy dx plus 2 x psi x. First of all, write down x dy dx plus 2 and the whole psi. So let's open it now. X dy dx plus 2 x psi minus x dy dx plus 2 psi. That will be, let's open it, x dy dx x psi minus plus 2x psi minus x d psi by dx plus 2 psi. Okay, so here it is x, isn't it? X, this is dy dx of x psi, that is dy dx of x psi plus 2x psi minus x x d psi by dx plus 2 psi. So this is your what? X, this derivative is psi plus x into x d square by dx plus 2x psi minus x square d psi by dx minus 2 psi x. If you see 2, okay, minus 2x psi, whatever, 2x psi, 2x, the same. So these two are cancelled. So what is the answer? X. Okay. So if you see, the answer is what? Ax is equal to x. I can write ax is equal to x. Can we can write it as x. Okay. What is the next one? What is the next operator? A divide x. Let's do it. A divide x. A divide x sine. Okay. So A is again x d by dx plus 2 d by dx sine. Okay. So again open it. First of all, x. Let me write it as x. Normally x d by dx plus 2 d by dx minus d by dx of x d by dx plus 2 and whole sine. Okay. So if I do it, let's open the bracket. Let's take sine inside. X d by dx plus 2 d psi by dx minus d by dx x plus d by dx plus 2 psi. Now I will open the bracket x d square psi by dx square plus 2 d psi by dx minus d by dx of open it x d psi by dx plus 2 psi. So that will give me x d square by d square psi by dx square plus 2 d psi by dx minus let's do this one d by dx of x d psi by dx minus 2 d psi by dx. Okay, so this will be x d square psi by dx square plus 2. Okay, these two are cancelled, isn't it? Yeah. Now this is minus, okay, d dx by dx, that is 1 with d psi by dx minus again x will go out and this one d square psi by dx. Okay, this is u into v. This is just not dx by dx is 1 and this is like no u into v. Okay, so if you see these two are cancelled now. So what is the minus d psi by dx minus d psi by dx? That means a and d by dx will give me what? Minus d by dx. That will be the answer. I hope you are clear. Is it clear? Okay, what is the next part of this question? A d square by dx square. So let's do this one. So this one, how will you do? I can write it as d by dx, isn't it? So this will go to this side. We have done so many times. This will go to this side like a comma bc commutator, b to left, c to left. So b ac plus sorry, a b and c in the right. Okay. So here d by dx a d by dx plus a d by dx dx. So here again we have to put an operator, put something psi. Okay, so let's now operate psi. dy dx. A dy dx minus dy dx of a psi plus a dy dx minus yes. ये प्रत्येक कॉल करूँगा. So this is becomes dy dx a d psi by dx minus d by dx of a psi plus this one becomes d square psi by dx square minus d by dx of a d psi by dx. Okay, so this becomes d by dx of a, that means dA by dx into d psi by dx. Okay, plus a d square psi by dx square minus d by dx of again this one also a d psi by dx plus dA by dx d psi by dx. Sorry, psi d by dx plus a d square psi by dx square minus again dA by dx d psi by dx minus a d square by dx square. This cancelled out. See, these are cancelled out. So yes, minus dA by dx d psi by dx minus a d square psi by dx square, then minus again d psi by dx dA by dx minus psi d square a by dx square. This term I'm doing. Now only this is left plus a d square psi by dx square. So these two are cancelled again. What is cancelled now? Okay, this is what is left. Okay. So what is left? This is minus 2 is we added d psi by dx dA by dx minus psi d square by dx. Okay. So just remove the, if you remove the psi, that will be the answer. Okay. What was the next one? Similarly, you can do it. I hope. This one also you try to do. So this is actually 0. If this and there is another same thing here, the answer will be 0. Again, see here, this is here, this is also inside, so this will be 0. So just remember that. Okay, next question. Next question will be the exercise 2.52. exercise 2.52. So, is the state option, first one is the state psi function of theta and phi is equal to e to the power minus 3 I phi cos theta, an an eigen function, first one. Second bit, sorry, no, no, eigen function of what? My bad. Eigen function of a phi is equal to del by del phi, and or of b theta is equal to del by del theta. So you have to decide which, like this state is the eigen function of which one, whether it is a phi del by del phi or b theta del by del theta. Second bit, are a phi operator and b theta operator, Hermitian, are a phi or b theta Hermitian. C. Evaluate the expressions. Evaluate the expressions. Evaluate the expressions. Psi a phi psi and psi b theta psi. Okay. Evaluate the expressions. Psi a phi psi theta. You find the commutator. Find the commutator. Find the commutator a phi b theta. Okay. Find the commutator a phi b theta. Okay. So these are the questions. Let's try. Is the state psi theta phi equal to p to the power minus 3 a phi cos theta, an eigenfunction of a phi is equal to del by del phi of b theta or del by del theta? Are a phi and b theta Hermitian? Evaluate the expressions from this. Find the commutator of this. Let's try. So what is given in the question? Your eigenfunction is given. So psi theta phi is equal to e to the power minus 3 I phi cos theta. This is an eigenfunction. What operator we have given? We have been given a phi del by del phi. So we have to check whether this state is function of this or that. So how to check? If a phi psi, I get I get the psi thing again. Okay, so that will be your that we will call it as the eigen, like this operator will work on this. Okay, so see, so a phi psi is equal to, is equal to del by del phi of e to the minus 3 I phi cos theta. Okay, so if I see um, del phi, so cos theta is constant, it will come out. Del by del phi, this one is minus 3 I e to the power minus 3 I phi. Okay, so if you see minus 3 I e to the minus 3 I phi cos theta. So if you see This is the eigenvalue. We are getting that value again. Okay, we are getting the psi thing again. That means a phi psi is equal to, if this is a and this is your psi, so I'm getting it again. That means this is an eigenfunction of this operator. Okay, yeah. So yeah, so this is, yeah, this is an eigenfunction. This is an eigenfunction of a phi. What about b theta? B theta psi del by del theta, del theta of e to the power minus 3 I phi cos theta. See, if the operator is changing psi, then it won't be the eigenfunction of that operator. So the e to the minus 3 I phi goes out, del by del theta of cos theta. So that is your minus sin theta. So minus sin theta e to the minus 3 I phi. So this is, if you see, I'm not getting that value again. This is cos theta, here it is sin theta. So I'm not getting that repeated value. So this is not, psi is not an eigenfunction of b theta. Okay? Is it clear? Because I'm not getting psi again. Okay. Okay. Next question is, are a phi b theta Hermitian? Next question is, are a phi and b theta Hermitian? That is the question. Are a phi b theta Hermitian? So how to check whether they are Hermitian or not? So we have to check their expectation values. If their expectation value comes real, then this is Hermitian. If it is complex, this is not Hermitian. If it is complex, this is not Hermitian. If this is real, this is Hermitian. Okay. So we have to check it. So a phi is equal to expectation value integration psi star a phi psi d theta divided by psi star psi d theta. Okay. So if you see this, psi star is what? Um, Psi is, or if I write psi into the minus 3i phi cos theta. Psi star is e to the 3i phi cos theta. Okay. So cos theta is there. This will be cancelled. So cos square theta, and the a phi will be del by del phi. Okay. So oh, okay, okay, my bad. Sorry, yeah. So psi star, I will write it as, this won't be cancelled. So 3i phi cos theta into del by del phi of minus 3i phi cos theta. Okay, is it right? Yeah. D theta integration e to the minus e to the 3i phi cos theta e to the minus 3i phi cos theta. Okay, d theta. This is all right. So now, if you see, the derivative is minus 3i, so minus 3 goes out, e to the power 3i phi cos theta into e to the minus 3i phi cos theta d theta. Derivative goes out, divided by integration this one. And these two are cancelled. So cos square theta d theta. Okay. So now minus 3i. This is a what? These two are cancelled now. This is also, if you see, cos square theta d theta, and the denominator also cos square. Now you don't need to calculate the integration. If you see, these two are same. Whatever the limits will be, the limit will be same, right? The upper part and lower part. So this is same. So I'm getting these two can be cancelled, like the whole thing, including integration. Okay. So the answer will be minus 3. So minus 3i is the expectation value of a5. That means this is not a Hermitian operator, because Hermitian operator have their expectation values as real, but this is complex, so this is not Hermitian. Is it all right? Is it all right? What about B? Let's do for B. B theta. Expectation value. Integration psi star. You can take integration or you can take like this also. Okay. The same thing actually we have to do the integration moving. Um, e to the power 3i5 cos theta del by del theta of minus 3i5 cos theta d theta divided by e to the power 3i5 cos theta minus 3i5 cos theta. This is one. Okay. If you see, this is also cancelled out because this won't be differentiated. So del by del theta of cos theta is what? Minus sin theta. So minus goes up minus sin theta cos theta d theta divided by integration of cos square theta d theta. So if you actually see, there is no complex number here. The integration of this will never be a complex number. Okay, integration of cos square theta will never be a complex number. So this value is actually real. So we can conclude that b theta is a Hermitian operator because its expectation value is real. Okay? B theta is Hermitian. Is it alright? Next. What is the next part in this question? Evaluate the expressions psi a phi psi a. We just did. We just did it. So yeah. Now find the commutator. Find the commutator a phi b theta. Okay, let's do this one. A phi b theta. So is equal to a phi b theta sine minus b theta. Sine is over e to the power minus 3i phi cos theta. So del phi del by del theta of e to the power minus 3i phi cos theta minus del by del theta of cos theta. So here, this is a function of theta only. So phi will go out as constant, but it won't go directly out. Okay, it will just be there. E to the minus 3i phi. This is minus sin theta minus del by del theta of um, cos theta will come out minus 3i e to the minus 3i phi. Okay. Next. So if you see minus when you go minus sin theta and the derivative of this one will be minus 3i into minus 3i phi minus this is minus 1 plus 3i again minus sin theta e to the power minus 3i phi. If you see this is a minus 1 plus, so this is if I write so plus 3i sin theta e to the minus 3i phi. This is actually ending up in minus 3i phi 3i sin theta the minus 3i phi. So this is cancel out 0. Answer is 0. So A, phi and B commute with each other, we can say, because their commutation we are getting as 0. Right. Next, write a homework. Write homework for it. Try to solve yourself. Exercise 2.51. Now consider the wave function. Consider the wave function. Wave functions psi xy is equal to sine 2x, sine sorry cos 5x, sine 2x cos 5x, phi xy is equal to e to the power minus 2 x square plus y square. Then chi xy is equal to e to the minus I x plus y. Okay, so what is the question? First bit A, verify if any of the wave functions verify if any of the wave functions is an eigenfunction is an eigenfunction of A is equal to del by del x plus del by del y. Verify if any of the wave function in an eigenfunction of A is an eigenfunction of A is equal to del by del x plus del by del y. Option B or bit B, find out if any of the wave functions find out if any of the wave functions any of the wave functions is an eigenfunction of B is equal to del square by del x square plus del square by del y square, okay, plus 1. Bit C, calculate the actions of A, B and and BA on each other, on each one of the wave functions and infer A, this is the question. Okay. You are given two operators A and B, you are given some wave functions, you have to calculate one by one. Okay. Next question. Homework 2.50. That is exercise 2.50. Consider a particle which is confined to move, which is confined to move along the positive x-axis, and whose Hamiltonian is whose Hamiltonian is h is equal to epsilon, h is equal to epsilon d square by dx square, where epsilon is a real positive constant, real constant only, a real constant having the dimensions of energy, dimensions of energy. Okay. The first bit is find the wave function that corresponds to corresponds to an energy eigenvalue corresponds to an energy eigenvalue, okay, of 9 epsilon. 9 epsilon. Normalize this wave function. Normalize the wave function. Okay. Option bit B. Calculate the probability. Calculate the probability of of finding the particle in the region 0 to x to 15. Okay. Bit C is the wave function is the wave function um, derived derived in A, an eigenfunction of the operator of the operator A is equal to d by dx is equal to sorry A is equal to d by dx minus 7. Option D or bit B is calculate the calculate the commutator H. Okay. So yeah. So these are some of the questions you please try at home. We have done these kind of questions. The more questions you do, the more clarity you get. Okay. So yeah, this is it for today, and I'll see you in the next session. Thank you very much.